Section 3.1, Chapter 3, Quadratic Function and Models. I put a few pages of lecture notes here for you off of the textbook. So here, graph of quadratic functions, normally there are three types of function. If the power of x is 1, is a linear function, which graph is a straight line. In case that you don't have any x, or just say you have x to the power of 0, then it's a constant functions like x equal 1, y equal 3. So let's say you want to graph x equal 1. What is x equal 1? Is a vertical line. Or y equal -5, it's horizontal line. And then you have a squaring function. It means when power is 2, then they call it quadratic functions. All three of them are polynomial functions. So normally, any type of non-negative integers and polynomial functions are written in this format. So that power of n can be a whole number. And these are some example of the second degree equation. See, the highest power of x is 2. And this one, when you multiply out, you see the power is 2. So quadratic functions, or they call it second degree functions, is when the highest power of x is 2. So you have x to the power of 2, x to the power of 1, and the constant number. The graph of quadratic function is a U-shape, and this shape is called parabola. There is a highest or lowest point of this parabola. The highest, if the parabola is open downward, then the highest point is the vertex. If the parabola open upward, then the lowest point is the vertex. The line that goes through the vertex, the vertical line that goes through the vertex, and split the parabola into two equal pieces, they call it axis of symmetry or line of symmetry. So this is a general equation for any quadratic. ax2 plus bx plus c. The value of a number that's sitting before x2, if that value is positive, the parabola always open upward. If the value of a is negative, the parabola open downward. So they call it leading coefficients, because the leader of this one is x2, and this is a coefficient, a number that's sitting next to x to the power of 2. And these are, see, a is less than 0, a is greater than. This is in case that you don't have, if b and c both are 0, then the special case of parabola is this ax2. So this is case that you don't have b and c. And these are some examples. So like the graph that we need to kind of memorize, which is the half bowl, is y equal x2. So what's the difference when the number in front of the x to the power of 2, the number or the leading coefficient, if it's less than 1, then you come up with the parabola, which is flatter, is the wider than the original one. If the number is greater than 1, 2, 3, 4, then you have a skinnier parabola. And you could tell all this by putting some numbers. So when we ask you to graph 2x to power of x2, when you put some number for the x and you find the y value, when you plot those points, you see that when the number is greater than 1, compared to y equal x2, the graph is getting close to the y-axis and getting away from the y-axis. So it's fatter or it's skinnier. So these are all examples of that. If you have y equal x2 and you want to graph y equal minus x2, then what we do is, if this is x to power of 2, you flip the parabola. This is minus x to power of 2. So you flip this with respect to x-axis. x2, y equal x2, y equal minus x2. There are two equations that we normally use for quadratic functions, and one is this. A in the parentheses x minus h to power of 2 plus k. These h and k are coordinates of the vertex. The coordinates of the vertex is h and k. And of course, when a is positive or a is negative, it tells you whether the parabola is upward or downward. So like when you have there is an example here. If you have these equations, you have to write it in that format first. When you write it in that form, then your h is negative 2, the h is negative 2 and y is negative 1. It's always opposite of what you see in the parentheses. So these are examples of the solution that you could actually see. This is another one. So if you have something like x2 plus 6x, this is an example. What you could do, you take half of this 6, which is 3. You add 3 to power of 2 and subtract 3 to power of 2. It's just you're adding and subtracting the same number. Then this 3, we had this unit that a to power of b to power of 2 is a2 plus 2ab plus b2, and a minus b to power of 2 is a2 minus 2ab plus b2. We are using this unit here. So half of 6 is 3. So this 3 now is x plus 3 to power of 2 minus 9. This is how to change x to plus 6, x to something like this, which is almost the same thing. If you simplify this, you get x plus 3 times x plus 3, it give you that, or just x2 plus 6. So you see, nothing is changed. The appearance has changed because you want to write it in general formula. So let's say you have another example. You have x2 plus, or let's say x2 minus 4x. Half of 4 is 2, so you're adding 2 to power of 2 and you subtract that. Then this 2 is x minus 2 to power of 2. Why is minus? Because there is a negative here, see? Minus 4. Example, x2 plus 5x. How would I do that one? Half of 5 is 5 half. And then this 3 is x plus half to power of 2 minus 1. What is 5 half to power of 2 is 25 over 4. Okay, so that's, you're using this rule to change all this to that 4. So equation of parabola is either written in this form or is like this. If you have it written in this format, then the vertex is H and K. If it's written like that, then the vertex has X and Y, right? But X, which is here in this edge, it's minus B over 2A. And how do I find the Y? By taking this number when you find it and plug into this equation to find your Y value. Other rules are the same. A is positive, parabola open upward. Here A is positive, parabola open upward. A is negative, parabola open down. And this value that you find here, they call it maximum or minimum, which in this case is K, or minimum. So you always see it in one of these two forms. If it's in the parentheses, remember H and K, what you have here for the X coordinate is always with the opposite sign. If this is, for instance, if this is -3, then this is 3, but if this is positive, like +5, then you have the -5 here, okay? Like here, let's say I have something like this. What's the coordinates of the vertex? 3 and 7. Well, let's say you have equations like that, right? What is the coordinates of the vertex? Opposite of this number, -1 and -5. The second one is okay. It's just the first one should be opposite of that. That's how to find the vertex if it's written in this form. Okay, and that's what they have here. So what is the minimum value? Is this Y value here. All right. To show you an example, let's say you have something like this. You have x2 minus 3x plus 7, right? In this example, you want to find the vertex. X of vertex is minus b over 2a, which is minus, what is the b value? Here, a is 1, b is minus 3, and c is like 7, right? Minus b, which is minus 3 over 2 times, there is no number here, it's 1. So is 3/2 or 1.5, okay? That's your vertex. Your vertex, you find the first number, which is 1.5. Now you need to find the second number, correct? Which is your maximum or minimum. You take these numbers and plug here in these equations for the x. So y is 1.5 to power of 2 minus 3 times 1.5 plus 7. That gives you the y value. So it's 2.25 minus 4.5 plus 7. So this 4.75 is your K, or is the number that you put here. This number is your maximum or minimum. Now, you want to know whether you have a maximum or minimum here in this example. What is the value of A? A is 1, which is positive, right? So the parabola open upward. In that case, you have minimum. So this 4.75 is your minimum. So in the problem, if we ask you to find minimum or maximum, A would determine that. If A is positive, you have minimum. If A is negative, you have the maximum. But the number in the parentheses, H and K or X and Y, the second number is always your minimum or maximum when we ask in the problems. All right. And then, here they ask you, these are the homework assignments. Y equal x2, what's the difference between that and this? Remember when the number is less, the function is fatter. This is in case is a negative. When it's a negative, you could either put some numbers and that would determine your graph, or you could just put by reflection. So you could use also the graphing utility. See, these are all, you could actually look at it. It show you how to do the different graph. So you could practice on this. This equation, it doesn't have any k. So when you write a vertex, vertex is 5 and 0, which is here. This is your vertex. A is greater than 0, so parabola open wordward, therefore this is your minimum. If you ask you what's the minimum, 0. See? Another way to do this is, if you know how to graph y equal x2, when you have x minus 5, opposite of negative 5 is 5. So that means you need to shift it on the horizontal axis 5 units. What's the difference between x2 and 4x2? Is just kind of skinnier, right? Remember we had the first one. When this number is greater than 1 in front of x2, then its graph is skinnier than x2. Like if x2 is like that, this is skinnier. But then plus 1, that means you shifted up. When the number in front of x2 is less than 1, then the parabola is fatter. It's flatter, okay? So remember, if this number is a fraction is less than 1 compared to y equal x2, is a flatter. If this number is greater than 1, then you have a skinnier graph. But this one is negative 2, means you have to shift it down 2 units. In the parentheses, you have positive 2. Opposite of that is negative 2. So you have to take the x to the power of 2, shift it to the left 2 units. They all are very similar. See what I did here. First, I want to change this to this format so you could actually see your H and K. You don't have to do that anymore, because if you already know how to use the other method for x2, you could also use this formula and find your vertex. Minus b over 2a is for your x, and then whatever the number is, put it back here. Say you could do that one here too instead of this one. Again, axis of symmetric is the x value. So x minus 2, you set that equal to 0. X equal 2 is line of symmetry. I'll show you how to use this formula. So if I want to write it in this form, coefficient of the x is 1. Half of that is half. Half to power of 2 minus half to power of 2. So you finally get this one. So what is the vertex? Opposite of minus 1/2 is half and 19. or 0.5 and 19, or half and 19. If they ask you to find the x-intercept is the place that your parabola would hit the x-axis. These are your x-intercept. If you ask you to do that, take the whole function still equals 0, use the quadratic formula, and find your values. This one, you need to use a graphing calculator if you want, but I'll show you the hand calculation for that problem number 7. See, half of 4 is 2 to the power of 2 minus 2 to the power of 2, and then you come up with this. Remember, this h and k, h also is axis of symmetry, x equal minus 2. So here they ask you for axis of symmetry, x equal minus 2, which is a line that goes here. You have to just rearrange this. So because you want to write it as y equal a times x minus h to the power of 2 plus k. So you always rearrange it. So you could actually see your opposite of this is your h and k is that. I have the solution for this tree. The vertex is given and 1 extra point. So when you have 2 points, you plug into the equation to find your a. When you find your a, put it back in the equations, okay? So the reason we give you 2 points, because we give you in the problem, we give you x and y, h and k. So you take all these 4 numbers and plug into this formula to find your a. And then you put the a back there, then you have your equation. That's the case for all of these problems here. Okay, so the rest is all graphing calculator for section 3.1.